Okay, I welcome you all, and today we are going to talk about a very important topic that is we want to realize actually symmetrical and asymmetrical situations, because what we are supposed to do is we are supposed to deal with. In physics, what we do, we deal with symmetrical situations and we deal with asymmetrical situations. So, in order to first make an imaginal manifestation of what symmetrical means and which kind of mathematical arguments can be incorporated in symmetrical, and then what we call as asymmetrical. So this is our target. So for this, if I tell you that you imagine that there is a valley, okay? It's a beautiful valley, and in this valley there is a tree, there is a stone, there is a car, there is a house, and there is a mountain, okay? There's a mountain. And when you will enter this valley, what you will see is corresponding to the mountain, there is another mountain on the other side, having the same geometry. Corresponding to the stone, suppose there is a stone, this stone is 10 meters away from the axis of this valley. You will find the same stone 10 meters away from the axis of this valley. And the same story goes with the car, the same story goes with the tree, the same story goes with the house. So that means this valley has a mirror image in it. Everything that you have in the right hand side of this valley is exactly existing on the left hand side of this valley. So I will say that this valley is physically representing a symmetrical valley. Symmetrical valley. But now I have a character. I will name this character as even. There's a character, you can call this character as a spirit, anything that you want to call it, but I name this character as even. Now this even is going into this valley. The even is walking exactly at the center of this valley. What it does, it spreads its right hand. At the same time, it spreads its left hand. Are you getting my point? So, whatever this even spirit does, with respect to its right hand, the same thing happens with respect to this even character, with respect to its left. This even is what we call as the even functions. You have a symmetrical valley and you want to realize what's going on in the valley. You take a character known as even, and this character is whatever it is doing with respect to its right, the same thing is happening with respect to its left. Clear? Now the even goes, does its job. I don't know what it does there. It comes back. Now another fellow comes. I name this fellow as odd. Now the odd goes. Now when odd goes, where odd is going? It's going into this symmetrical valley. You have a valley. The valley I described in the very beginning. Okay? The odd goes when the odd takes his hand up, its left hand goes down. It takes its left hand up, its right hand goes down. So this odd split, whatever it does in one act, the opposite happens at the same time in the same act. It raises the hand, at the same time it lowers the hand. Right? So you have two symmetrical mathematical arguments. Now see, one argument is the even argument. Okay? Even is smooth. Whatever it does with respect to its right hand, it has to do everything the same way it does with respect to its right hand. And then moves the odd. And whatever it does with respect to its right hand, everything else happens opposite to what he does with respect to his right hand. Now both are beautiful. This valley is a beautiful valley. There is a perfect harmony in it. There's a perfect symmetry in it. And you can describe this valley using these two characters, the odd character and the even character. Clear? Now what happens? A comet comes. A comet comes and it hits this valley. You have two characters that are describing this valley. One is odd and another is even. The comet has come, it has destroyed one side of this valley. Now there is asymmetry. Now even is going inside and even is not able to balance itself the way it was balancing when the valley was in its original shape. The odd is going, the odd is taking right, it is taking left, but they are not perfect. It is more right, less left. The even is doing more right, less left. They are not able to describe the things. They are not able to describe the properties of this valley. And they sometimes join together. They join together, and when they join together, still you are not able to get the symmetrical results that you could get when there was this full-fledged valley that I described in the beginning. So now what's happening? Now you have a complication. Your functions, your mathematical functions, they are disturbed. Now it's very hard to know about the valley. So there are complications. The valley that you have now, which has been hit by this comet, is an asymmetrical valley. And what we can do as mathematicians, we can try to describe this asymmetrical valley in terms of these even functions and odd functions. Are you getting my point? Now we realize what is an even function and what is an odd function. We can have an example. The basic equation that we have here is Schrodinger's equation, right? Okay, so what we have a situation like this, and we can have a situation like this. This will reflect our even character. If I draw an axis of symmetry, sorry, this figure is not so beautiful. So it's a symmetrical parabola, right? So as much you will go right, that much you will go left. Right and left. So this you can describe using the even functions, right? And here you have a symmetry, but One thing is happening up, another thing is happening down. So you can describe this thing as odd. So anything that looks awkward, something like this, if I call all of these things as potential, this is symmetrical, this is also symmetrical, even though it is periodic. This is an asymmetrical potential. Okay? But the tools that we have are even and odd. So you are trying to, here you can describe using your even functions, here you can describe using the odd functions, and here you try to describe this asymmetrical formalism in terms of these even functions and odd functions. Now, we can have an example of even function. Yeah, what's that? Yeah, if I have a function f of x equal to x squared, is it an odd function or even function? Yeah, it's an even function. Why? Because if I replace this x by minus x, what I'll get here, minus x whole squared, this will give me x squared. That means a function is even when f of x is f of minus x. Right? We have another example of even function. Can you tell me what's that? Come on. You might have forgotten those things, but yeah, cos x. So if you have something like this, f of x is equal to cosine of x. Okay? Now what you will do is, you will replace this x by minus x, right? When you replace it by minus x, you will have cos of minus x. But all of you know that cos is someone who eats the minus, okay? It kills it. So what you will get here? You'll get here cos x. So again, the same situation you have for the even function, that is f of x is equal to f of minus x. So this is your another example of even function. And similarly, if you have to think in terms of f of x equal to x cubed, it will be what? It will be odd, because in that case you will have a negative outside. And the same story will go what? The same story goes in terms of if I take a simple trigonometric function like f of x is sine x. Okay? So what will be f of minus x? It will be sine of minus x. But here you can't kill the negative sign, it will stay. So I will say that sine of x is an odd function. Clear? So does it relate with your value? It relates. For the even function, take right. The same thing you have to do in the left. The same magnitude. Okay? But in case of odd, if you raise one hand, the other hand will go down. That's why for the odd function, you will always have a negative, right? F of x is equal to minus times f of minus x. And that will lead us to the odd function. So what they do, they describe that symmetrical valley. It describes the energies of that valley. It describes the wave vectors of that valley, right? And they are the starting tools to describe what? The asymmetrical valley. A valley which has been shot by a comet, which has lost its symmetry, right? You try to realize the properties of that valley using even and odd, but they fail in doing so. They fail in doing so, but that's why we have mixing of odds and evens to describe the asymmetrical valley. So with this, if anybody has any queries, you can tell me. Come on. Any questions? Okay, so thank you all.